This is the part that we are doing. Okay, this is the class diagram. This class diagram we are going to understand today. Okay, this class diagram. So class diagrams is a class diagram is a diagram describing the static structure of a system. Remember, it's a static structure. It's not in the runtime. It's just like the structure how different classes will be formed out of the requirement analysis and how these classes will interact with each other. What kind of
So
message?
it's basically the class, the requirements of the class and its interactions.
And their interaction,
The classes.
how they are related to each other. I will tell you there are different relationship. There are different relationship in a object-oriented technology. Class relationship, okay? How they are related to each other. How they are, sending messages to each other.
Attributes.
Attribute.
Attributes.
How because a class, a class is depicted in a UML. Not only in UML, in any kind of object-oriented technology, there are few things, right? Attributes, or this is also known as states, right? Attributes are also known as
Yes.
states, and
I
behavior.
liked it.
And behavior are also called, I mean, the methods are also known as behavior of the class, right? All right. So this is what the static relationship. Now remember, the dynamic relationship, for example, what is going on in the runtime, these are depicted by something called sequence diagram. Okay, this is something called sequence diagram, which we will also see later. I mean, after we finish the class diagram. Okay, so this is the sequence diagram, and then see these are the different relationship. These are the different relationships of a class diagram. There is dependency, there is aggregation, there is composition, there is inheritance, there is realization. There are many aggregation, composition, inheritance, and realization, and there are many. These are the
What are they?
these are the various available relationship between two classes. The two classes may be related to each other by any of these things. Okay. Now there are
Can you explain me each of them?
I will explain it to you. Everything I will explain. There are many variations of dependency, but that is beyond the level of this discussion. But for the time, remember there is a dependency. We will take only one dependency, okay? Not the other variations of dependency, okay? So dependency, aggregation, composition, inheritance, and realization. You have already seen all these things. I will already seen some of the things.
The inheritance I've seen.
So we will realization. Have I told you about the interface? Interface I have told you, right? From abstract class you can define the interface if all the methods are abstract, right? In an abstract class, if all the becomes abstract.
Yeah.
Tell me. Go ahead.
And final. What I should say.
Member variables.
Member
variables should be final and constant, right? That's what constant. Member variables should be constant, right? That's what you have learned, right? And there are other things like in the new Java architecture, like default and all these things, but we haven't discussed all these things because there is no need to discuss.
Default, you told me. Default type.
No, default method. There is something called default. Yeah, default type of method. Yeah.
Default method. Yeah.
You have. I have told you.
Yeah.
Oh, okay. Anyway,
it can be anything to any class within the same package.
Right. No, not that. That is the default access specifier. I'm talking about there is something called default in the interface and abstract class. Okay. There is something. There is a kind of default methodology. Default method, not method. Default method, not methodology. Method. There's something called default method. So we haven't discussed that part vis-a-vis abstract class and interface because we are not. These are the new addition in the Java language. Okay, in Java, I think default has come into the Java 9 or 10. Okay, these are the new addition of Java language. The Java language is evolving, so that's why these are being added. Okay, don't worry, we will learn as we progress. Okay, we will learn. These are the new additions, so there is no need to learn at this moment. So we will learn as we progress. Okay, so first thing we will learn about the composition. Okay, first thing we learn about the composition. Now let me So, so association, okay. Two classes. There are two kinds of association. One is the composition, and let me show it to you in the UML. Let me show it to you in the UML. See, this is the, see, in the association, see, this is the association, right? Able to see, right? This is the UML
Yes,
class. This is the class diagram
I
of
can
the.
only see this. I can only see this PPT.
You are able to see only the PPTs.
Yeah.
Oh, not this person. Let me. How can I share it now? You are not able to see this. Whatever I am sharing right now.
I can only see the PPT.
You are seeing only the PPTs. Okay, then let me. Oh, the zoom. Okay, zoom. Okay, then share.
You can stop sharing this and share that instead.
Oh, okay. I have done it now. I've done it. Okay. You're able to see it, right?
Yeah.
You're able
No,
to
I
see
can't
it.
see it. I can't see it. I can only see the PPT.
Oh,
Stop sharing and then share
oh,
the
again, right?
thing.
Stop sharing. Okay. And then share again, right? Okay.
Yeah.
Let me do it. All right. Now I share it. Now share the screen. Okay. Now,
Did you stop sharing? It's still sharing.
I have stopped share. Then I have shared it again.
Stop sharing and
I,
let the. Okay,
I
yeah,
have.
I can see now. I can see now.
Oh, okay. This is because, okay. I'm sorry. I've stopped sharing now. I'm again sharing it. So I'm sharing it. All right. Because this may be because of the delay in the transmission. Okay. That's the
Okay.
telecommunication part, right? That's
And what is this?
this is
Looks like a
called the,
mess to me.
this is, yes, this is now complicated. This will look complicated for you because you are here learning. Okay, you are still at the learning phase. This is the class diagrams of the restaurant problem. You remember we did the restaurant problem for use case
Yes.
analysis. This is the class diagram of that restaurant problem. How different classes have been created. The restaurant class, bill class, cashier class, table class, menu item. These are the different classes that have been defined, that has been designed from the use cases of the restaurant system. Okay. Now, as I was telling you, there are two kinds of association. One is the aggregation and the other is the composition. See, association class. See, I'm let me show you. See, association, the relationship between two classes. See, one is the aggregation. You were able to see it, right?
What? Tell me again.
Aggregation. See, you are able to see the aggregation part, right? The left side part, left side.
Left side.
Association.
Association with
Ag- ag-
association class.
Aggregation and composition. There are two types of association, right? Aggregation and composition.
Aggregation. I can't find aggregation.
No, it is not coming in the screen.
I can't see where's aggregation.
No.
Where's aggregation?
Okay, if you're not able to see,
I can see association.
okay, association has two kinds. Actually, on my screen, these are showing two. These are the two both kinds of association. One is the aggregation and the composition. I'm not sure why this is not transmitting to you. Anyway, so there are two kinds of association. One is the aggregation and the other is the composition. Okay. Now we will discuss both the things. Okay. So let me. You have already seen this thing, aggregation and composition. I will show you once again from the code. Composition means it's the has the relationship. So that means a bigger class owns a smaller object.
Made a smaller classes
Yeah,
or objects.
bigger objects are made of small objects. For example, car has small objects like wheel, like engine, like AC. So car has small objects. So this is what you are able to see my desktop, right? Now car,
Yeah.
car class. You are able to see the car class?
Car class.
Oh,
I
it's
can
not.
see a restaurant.
Oh, what is going on? Actually, let me. Will I have to share it once again or what? Okay.
No, it should work if you share the full.
Because I.
It should work.
Okay, let me share. The desktop. I should share the desktop. That's it. Share screen. That's it. You are able to see now
Yeah.
the Eclipse Java code.
Eclipse.
There
Wait
is
just a sec. It's starting to share.
okay.
Take some time.
This is the transmission part, right? Telecommunication part, right?
It still hasn't shared.
I have shared it. You are not able to see right now.
It's just saying that you have started sharing screen.
Okay, let me. Probably this is because of the low speed of the internet. This is because of that. Let me do it. Let me do it. Let me. I have changed my internet service provider. Okay, I have, transferred it to Airtel mobile now. Let me see how it works. Probably it will take some time, but now are you able to see anything?
Just a blank screen.
Just a blank screen. Now it will come.
It's flickering.
It's flickering.
I can see the UML that you've created.
Not the Eclipse, right? You're not able to see the Eclipse, right?
Not Eclipse. Not Eclipse.
Because I have shared the. I have shared the. Hang on. Yeah, I've shared the desktop. So whatever
If
comes.
you share the full screen, you can change. Yeah, I can see aggregation composition. I can see.
No, you are able to see the Java code. Car class car. You are able to see that. Car class.
What?
Car class car. I'm showing you the some code, Java code.
I can see the restaurant and the aggregation composition.
That part, right? That screen, right?
Yeah.
Okay, let me share. Let me share in then. I don't know what is happening going on. So this is I'm sharing the share screen. Okay, okay, probably now you will be able to see it. Okay, so you are able to see the car class now.
It's just. I think it'll take some time.
This is
Yeah,
the
I can
top.
see.
Yeah,
I can see.
okay. So this is the car has or won't wheel. Okay. Now there is a catch. There is a catch here. So what is that catch? The difference between aggregation and composition is that in composition, this is composition. This is nothing but composition. Okay. Remember composition. Now in composition.
Basically, it's a has. It's a has.
Yeah, has and owns and composition, right? You are able to see the text, right, that I'm typing?
What text?
That I'm
I can
typing
only
something.
see. No.
I'm typing something. You are not able to see that?
You're not typing anything.
No. What is going on? I mean, it's horrible.
It'll take time.
Yeah, I mean, it's very.
Let him explain.
Okay. Okay. In composition, the lifetime. Remember, very important part. The lifetime of the smaller object is equal to the lifetime of the bigger object. Very important. Very important.
Okay.
Very important lesson. Okay, lifetime. So if the car goes away, if the car object goes away, all wheel, AC, engine, all these objects will go away.
Okay.
Okay, so the lifetime of the smaller objects are same as the lifetime of the bigger object. That's a container object. Okay, this is what is called composition. Okay, This is what is called
Okay.
composition. Now let me
Yeah.
give you some gyan on aggregation. So as I told you, there are two kinds of
Yeah,
association.
I can see your type.
Okay.
Composition
In composition, the lifetime of the
of the
smaller
smaller object is
is
to the lifetime of the
equal
uh,
to the
uh,
lifetime
lifetime
of
of
the
the
container
uh,
bigger of, okay. Okay, so lifetime of the, in composition, the lifetime of the smaller objects is equal to the lifetime of the container bigger object. Okay, so when the car object is gone out of the memory, then it will take away everything like wheel and engine and AC, everything. Okay, so this is basically,
yeah.
so car has the ownership, car has the ownership of wheel and AC and engine. This is also known as owns. So car owns wheel, car owns AC, car owns engine. Okay, now let me give you an example of aggregation. Aggregation is also kind of composition, not kind of association, where the bigger object has smaller objects, but the bigger object does not own it. Let me give an example. Suppose
Okay.
in a football team there are 11 players, right?
Yeah.
So the football team owns the players, right?
Yeah.
But
Yeah.
if the football team is dissolved, the players will still be there, right?
Yeah.
So the big, so the football, although the football team owns the players, the lifetime of the players is different from the lifetime of the bigger object, right? Container object, right?
Yeah.
Agree?
Yes.
For example, suppose I will show you the example of the employee class, using the employee class. Remember, we did that something called employee class, right? Few days back, doctor
Yes.
or engineer. I will show you that example. Okay. So, for example, employee class. A office employs few people, but so
Yeah.
office actually owns those people in the during the office time, right? But when even if the office is closed, the employees are still available in the market, right? They are not dead.
Yeah.
So the employee's lifetime is different than the office, the container object's lifetime. Okay,
Yeah.
agree? All right. So this is what is
Basically,
called
composition is the same lifetime and aggregation different lifetime.
lifetime. Yes, this is very important. Okay, so let me show you the uh, employee class. So this is the you are able to see the employee class now, right?
Yes.
This is
Yes.
the
Yes.
different class. The employee class. You remember you did it. Now see, I have
Yeah.
created another class called organization. What I did, so employee organization has a list of employee, right?
Yeah.
Organization has a list of employee. Okay,
Yeah.
and but these list, so organization has more all the employees, right? Organization, an
Yeah.
organization is constituted by all the employees. But remember, even if the employee, even if the organization is closed, the employee will be still there. Okay, maybe the list will go if when the office is dissolved, this list will go, employee list, right?
Yeah.
They are out of the payroll, right? But they will be available in the market, right?
Yes.
So this similarly, see, this is the main thing, main part. See, so you are creating a doctor here, and you are inserting the doctor in the employee list. You are inserting the doctor in the organization's payroll.
Yeah.
You are inserting that doctor, you are creating an employee called doctor, and you are inserting that doctor into the organization's payroll, right? In the list, right?
Yes. Yes.
So as this list, So when the organization goes away, as the organization is composed by this array list, so this list will go away, right?
Yeah.
But even if the list goes away, this doctor will be there. This doctor will be there, right? Because you are creating the
Yes.
doctor in the main class, right? So
Yeah.
this doctor will be there. So list will be emptied. So list payroll will be emptied, but doctor will still be there, right? So this is what is called as aggregation. This is a weaker form of composition, because although the office employs few people, but office does not own them, right? They
Yeah.
This is the weaker form of association or composition. In ownership,
Yeah.
if the car goes away, it will take away all the wheel and engine and AC, everything, right? So this is a
Yeah.
stronger form of association, and weaker form of association is aggregation.
Yeah.
Okay, agree?
Yeah.
You are getting the point. All right, now let me show you something. So now if I stop share, and if I go to again share, if I show this thing now, share screen. All right, so aggregation, and you are able to see the this thing, right?
Yes. Yes. Yes.
This one. Okay, this one, right? Able to see this one, right? All right, now
Yeah.
so aggregation and composition is done, right? Inheritance in
Yeah. Inheritance.
inheritance, you know, right? Inheritance,
Yeah.
that for employee, from employee you are inheriting the doctor. So inheritance is
There's employee superclass, and in doctor, engineer,
all
teacher are also classes who are who
is
who
a
is a
employee.
employee.
Yeah, doctor is the employee, engineer is the employee. So inheritance is like kind of is the relationship, and realization is, as I told you, realization when you implement an interface. Like in inheritance, you extend the class, right? Extend the superclass.
Yeah.
But in realization, you implement the interface. So for example, if you have an interface,
Implement meaning.
I have told you interface.
Yeah.
Have I told you interface earlier?
Yes. Yes. Yes.
Okay, we can extend the class, right? We can extend the class, but we have to
Yeah.
implement the interface. That's what I showed you, right? Implement. Experimentation with interface. Remember? If you don't remember, let me show it to you. Let me show it to you then in that case. Okay, let me show it to you. This thing. Okay, let me, you are able to see the this thing, right? Now let me show it to you. Experimentation with interface.
Yeah. I can see.
Experimentation with interface, right? See, this is the thing. Let me show it to you. As I told you, experimentation with interface. So this is the interface. This is the interface. This is the interface. Experimentation interface. In interface, everything, all the methods are by default abstract, and we can implement the interface, right? We don't extend the interface. We implement the interface, right? We implement the interface. Public class, implement the interface, right?
Yeah.
We don't extend the. We can extend the class, but we will have to implement the interface. So when we implement an interface, that is called realization. That is called realization, okay?
Okay.
When we implement an interface, that is called realization. Means because interface cannot have a concrete class, right? We cannot create a concrete object from an interface, right?
Yeah.
We will have to just subclass it. We will have to create concrete classes from interface. We cannot create object of interface. We'll have to subclass it. We will have to just implement the interface. That's why
Yeah.
we are realizing the contract. We are realizing the interface. We are creating real concrete classes from the interface. That's why it is called realization. And Sometimes the inheritance is also called, in terms of UML, this is called generalization, because we are extending the superclass and creating a subclass. This is sometimes called generalization. Okay. Okay. So there are two things you have learned. Four things you have learned. One is aggregation. Another is
aggregation,
composition,
composition, inheritance, and realization.
and realization. Okay. Realization, when we
And
implement an
dependency.
interface. Dependency. That dependency I will tell you now. Dependency I will tell you. Okay. Dependency is when, let me show you the dependency part. Okay. Let me stop here and let me share the class diagram. Okay. Share screen. Okay. You are able to see the class diagram, right?
Yeah.
Okay. Dependency means when an object of a class is passed through the as a parameter to another class. Okay.
What?
When an object of a class is passed as a parameter of a method of another class, parameter to a method of another class, then whoever has that method which is being passed the parameter object of as a parameter, that then first class is dependent on the second class. For example here, see, when the waiter, see the dotted line, this dotted line are dependency. Okay. So what is this? What is, so the this is the you are not able to see. It's probably this one is probably okay.
I can see.
Okay. So this is the cashier generates bill. See here, top one. Cashier generates bill. Okay. And then here, see, waiter displays menu.
Waiter displays menu.
Waiter here, you are not able to see. Waiter, see, this is a dotted line.
Waiter,
I can see. Waiter and then displays on top menu. So waiter is dependent on the menu, right?
Yeah.
So menu class is not dependent on waiter, right? Does a menu depend on waiter? But waiter depends on menu. If there is a change in menu,
the waiter needs menu in order to show.
But menu is not dependent on waiter. Menu can
be dependent on items, right?
Yes, menu is dependent on items, maybe, but menu is not at least dependent on waiter, right?
Yeah.
So waiter depends on menu. So that's how this is known as the dependency, when one class depends on another class. And this is sometimes also called as client and supplier. So the menu here, menu is a supplier class. So supplier is not dependent on the client class, but waiter is the client class. So waiter needs menu class to show it, right? Waiter needs menu object to show it. So waiter needs menu, but menu does not need waiter. So waiter is dependent. Waiter depends on menu.
Yeah.
Okay. Now how to do it in pure Java code? Let me share it and let me again share it. Stop sharing and share it. Let me show it to.
If you share a full screen, you don't need to stop sharing.
I am doing it, but you are not able to see. That's why I am doing it again and again. So now let me show it to you. You are able to see that.
Full screen.
Eclipse you are able to see, right?
Wait, this is not the Java code. This is not the Java code. This is the UML you've created. Yeah, now you can see.
Now you can see. That's how it is taking time. It is lagging. That's what. I know. If I see in the desktop, then everything should come, but it is lagging time. Okay. So now see, where is the experimentation in this thing? I'm closing it. See, now let me show you how the dependency is done in Java. For example, here cashier generates bill, right?
Yeah.
So cashier, so the cashier generate bill function is taking a customer as its parameter, right?
Yeah.
So that means cashier is also dependent on customer.
Yeah.
Because if customer changes, if for example, if the number of days of customer changes, cashier will also change its generate bill. Cashier generates bill method will be affected, right?
Yes.
So cashier is dependent on customer. So that's how
Yeah.
cashier's generate bill method is dependent on customer. So cashier
Yeah.
depends on customer.
Yeah.
This is what is called dependency.
Okay.
This is sometimes also known as uses. When dependency, how is dependency done? When an object of a class is passed as a parameter to the method of another class, right? The
I
generate bill
remember that we had done this once. I remember we had done this once.
in my class.
We've made an object as a parameter.
Maybe yeah, we have done it, but we haven't discussed it in the light of UML. Many a times we will do it, but we haven't discussed it in the light of UML,
UML.
right? We haven't discussed it in the light of
Yeah.
UML. So unified model language. So this is how the dependency actually is depicted. So whenever the object, so here the customer object is passed as a parameter to the generate bill, right? So that means
Yes.
generate bill is a function of cashier. So that means cashier is dependent on customer. So if the customer changes, cashier will be affected, right?
Yeah.
If the customer changes, cashier will be affected, right? So
Yes.
cashier depends on customer.
Yeah.
Okay. So this is how the whole. So you have learned some of the terminologies of class diagrams. One is you have learned about composition. You have learned about aggregation. You have learned about inheritance. You have learned about realization, and you have learned about dependence, right?
Yes.
There are many forms of dependency. Actually, there are instantiates, and you know there are a lot of things in UML terms, but the most important form is users. That is the when this kind of relationship is there, when the object of one class is passed as a parameter. There are many forms of dependency, but because we are not trying to accumulate as much knowledge as much knowledge in UML as we want to accumulate knowledge in Java, right? We want UML, we want to use
Yeah.
UML to develop programs. We are not going to become an UML expert, but we will become something like Java expert, okay? If we by using the UML. So we are not going in details of all kinds of dependency forms of dependency relationships, but let's remember that whenever an object is passed as a parameter of to a method of a class, the second class is dependent on the first class. Okay, all right. Okay, so now what we will do, we will try to understand how this restaurant object, how this restaurant class, how this restaurant problem will be solved. Like for example, I told you, right, whenever the restaurant problem, first it will be use case diagram, right? Then those
Yeah.
use case diagrams will be given to the technical project head or the technical architect. Technical architect will have to dig into the use cases, and he will have to figure out what are the classes that are available, what are the classes that should be present in the whole system, right? So he will have to design all the classes from scratch, right? So
Yeah.
that part we'll cover in the next day, but we will start today. But gradually we will you will get a hang over it. I mean, how to do that thing. Okay. So let me first of all, for to do that, where is the okay. To do that, class diagrams, and so these are the different. You are able to see the presentation, right?
Yeah. Let me just see. Let me just see.
Yeah.
As class B has class A, class B owns class A, and class B is a class A and realize is interface class A. So basically for dependency class B uses class A, right?
No, class A uses class B. That means an object of class B will be passed as a parameter to a method of class A. A uses B. A is dependent on B.
A is dependent on B.
Yeah, that's
Okay.
the arrowhead. A uses B. That means A is dependent on B. That means the object of B will be passed as a parameter to some methods of A.
Okay.
Okay.
So class B is class A, right?
Class A is dependent on class B. So class
No, I
B
meant inheritance.
inheritance, right?
I got-
Inheritance is class B subclasses class A.
Yeah, and this realization class B implements interface class A.
Yes, implements or yes, those ELIs. Yes, implements interface
Implements.
interface A. Yes.
And for aggregation class A has class B.
Yes, one is has and the other is owns. I told you, right? Has and
Yeah.
own ownership.
Yeah, I understood all this.
All right. So you are getting the idea, right? How big
Yeah.
projects are being done, right? It's not only
Yeah.
writing few lines of code. Remember, yes, that's why the technical architect and these people are so highly paid because they have to scratch their heads a lot of time. Okay, so this is how all the things done. Okay, then so this is all right, right? There is no problem in this, right? Then
Yeah,
I have explained all these things, right? Dependency when an object is passed, right? Then aggregation, composition, memory installation, customer installation, there's installation.
realization
So,
and
so
system.
so now the technical architect's responsibility is to find out what should be the classes present in the restaurant system, right?
Yes.
What should be the classes they present in the restaurant system. That is done by this. uh, First of all, you need to figure out who are the actors or
Major
who are the
actors
major
first.
actors and who are the entities. What are the entities? Okay, entity means what are the basic entities, because the actors will interact with some entity, right? Actor will use some entity, actor will use some object, actor will use, so all these things will have to figure out. First of all, the actors classes, major classes will be the major actors. So customer is actor, reception is actor, waiter actor, cashier actor. Okay, so there is no other slides actually. So this way you will find the major class. Then you will have to figure out who are the major entities. For example, bill, cashier will generate bill. There will menu will consist of menu item. Okay, menu item. Then when a customer places an order, there should be an order entity, right? So we need to find out what are the major actors. So those will be one single class. And what are the major entities that the actors will be using.
Yeah.
All those
Just
things.
to mention, menu has items.
Menu has item. Absolutely correct. Yeah. So menu doesn't own it. Even if the menu goes away, menu card goes away, item will be there, right?
Yeah.
That's what menu has item. Very good. A office has employees. A football team has football players, right?
Yeah.
Very good. So you are getting the idea. Very good. That's what students should learn this way. Okay. So these are the things. So first you need to figure out who are the major actors and who are the major entities. All those things will be first translated into the classes, object-oriented class. Then you will have to find out
Just
what should.
can I tell two things? So the restaurant system owns items, but the restaurant system has cashier.
has cashier, has customer, has everything, right?
But the restaurant system owns items.
Restaurant system owns items. Yes, restaurant system owns items, because if the restaurant is gone, items will be gone, right?
Yeah.
We need to figure out the relation. We'll figure out all the relations. But you are getting the idea. That's the beauty of it. You are getting the point. So that's how we should understand the object oriented technology. Okay. So very good, very good. You are understanding. Fantastic, fantastic. I'm loving it. The way you are progressing. I'm loving it, sir. You are learning genuinely. So first of all, how do we translate those use cases? First of all, we need to figure out who are the major actors. Then we need to figure out what are the major entities. Here entities are cashier, bill, menu, items, then tables. Because book a table, you need to book a table, right? Table will be one entity, right? Whenever a table is vacated, you need to notify somebody, right? You need to notify somebody this table is empty, table is order. Yes, of course, order, all these things. Order, yeah, order is, I mean,
Item.
say order. So I order, in order there will be one item and how many plates of that item, right? Because customer will place an order. So customer will choose an item and he will tell the waiter how many plates of that item he needs. So in an order class, there will be two things. One is the item and the other is the number of plates of that item, right?
Yeah.
So that's all. And customer will depend, your waiter will depend on the order or whoever. I mean, then I think there are other classes as well I have developed: order, menu order, and item order, and a few things. So we'll discuss all these things once you go to the code. Okay, once we start going to the understanding the restaurant code, we will first of all we will need to dig out the class diagrams, how we have come out of with this class diagram. So this is the way that technical architect will figure out the classes. Okay. So now, then once he figure out what should be the classes, he will have to find out what should be in the class.
Yeah.
So these figures are little stale, because I initially did it, then I did a screenshot, but then later it got changed. Okay. So let me show you the actual item. See, this is the where is the customer? Where is the customer? So this is the restaurant class. Where the customer? Customer is somewhere. Menu customer. Here is the customer. See, here is the customer. See, here is the customer. You are able to see the UML diagram, right?
Where?
UML?
Yeah, I can see.
Visual paradigm? Yeah, UML?
Yes.
All right. So this is the customer class. So every customer will have a customer ID, right?
Yeah.
At least in respect to the restaurant, whenever a customer enters the restaurant, he will have a customer ID. Or whenever a customer, occupies the table, he will be given an ID, right? Because that's how the restaurant and cashier and waiter will be automating all his movements, right? What he's ordering, what is so everything will be against that ID, right?
Yeah.
Whatever cashier will generate bill using its customer's ID. Waiter will deliver food using customer's ID. Cook will get notification using the customer's ID. Whatever customer is, how the customer is placing an order, right? So customer. So now it's the responsibility of the technical architect to put in data inside those classes. First, you will figure out what will be the classes. Then you will figure out how these classes what will be the behavior and states of these classes. So for example, let's see the customer. So there will be four attributes: customer ID, customer name, order, and allocated table ID. So every customer, every table will have its ID, right? So that table ID will be a part of customer. because whenever customer will be allocated a table, this table ID will have this data. Okay, and then all the data set, nothing else. But see the restaurant part. See the restaurant part. Get restaurant, get table, all these things are there. Okay. Say goodbye to customer and all these things. So restaurant class is long. Restaurant class, this is the main class, main entity, restaurant class, main entity, restaurant class. Then item is this like this. Set price, set item. The item order is, see how many number of plates. Item. So one is the item order constitutes of item and the number of plates. Whenever so whenever customer places an
I
order,
don't understand one thing. Why is the menu given has instead of owns?
menu owns item, because I will have to find out. I'll have to why this has been done. Probably, I'm not sure. But let me. It may not be the case. Menu owns item, or see
Restaurant.
actually if the menu goes, because menu is with respect to the restaurant, right?
Yeah.
So if the menu goes, item doesn't have anything related to the
I meant restaurant to menu. Restaurant to menu.
restaurant owns menu and menu owns item, right?
No, restaurant owns menu. Menu has items.
Menu has item. Maybe I will have to figure out what exactly has been done. Maybe there is some
Items
mistake.
don't go.
Items don't go, right. Maybe yes.
I
That's
think
true.
both of them should be owned because both of them goes where restaurant goes.
Both of them. So that's how. So menu, restaurant owns menu and menu owns item, because if item menu goes, probably the item will also. I will have to figure out. We'll have to find out, exactly what has been done in the code. Probably there is some wrong depict, picture here. Wrong depictment. May not be menu owns item, but menu has item. Probably we have to figure out. Okay, but correctly you have put it correctly. You have understood it correctly. Okay, so see, item is item, and item order is item plus number of plates, and then order is different. So order will constitute of a list of item order. That means, because there may be 3-4 items, that 3-4 item order a customer will place, right? Tea 3 cups, coffee 5 cups, milk 9 cups, and dosa 10 plates, right? So item order will be list of item order a customer will order. So a customer's order will have list of item order, right? Item order is item plus number of plates.
Okay.
And then in the customer's order, there will be a list of item order. So dosa 9 plates, tea 5 cups, this way. Okay.
Yeah.
Okay. All right. So we will dig into the code. The student will gradually, try to understand how these things are being done, one by one, and then all these things will, become very.
When can we start using the visual paradigm?
See, one thing you can start right away, because you can because okay, let me show you. Say this is the association uses, so you have to that, let me
It looks quite complicated to me.
it seems
I
very
understand
complicated.
small parts.
Yeah, I'll tell you. Then hang on. Project. What is
Can you
that?
show me a simple one?
I'll tell you. I'll give you. I'll show you. What is happening? Why this is not working? Project. View. So, okay. This is because now view print browser. So this is now class diagram. Say this is now employee. Okay. Employee. This is our employee class. Okay. This is our employee car. You're able to see that the screen. So car, see this car has engine, speaker, AC, right? And
Yeah.
this is the generalization: employee, engineer, teacher, doctor. That's what you have done, right? And this is a car. So
Yeah.
these things are called the number you are seeing, right? In the car owns this engine, speaker, AC, right?
Yeah.
So these are called multiplications. These numbers you are seeing,
Yeah.
4 1 0 0 to 1,
Yes.
these are called multiplications. So that means car may have 0 or 1 AC, car may have 0 or 1 speaker, but car will have 4 wheels. So this should be wheels. Okay, this should be wheels. This should be wheels. Okay, this should be wheels. So car will have 4 wheels, car will have 1 engine. These are called multiplicity. Okay,
Some cars have 4 engines.
4 engines. Okay, racing car.
Four drive cars.
Oh, okay, racing cars and all these things have more engine, but you
No,
know.
not racing. Four-wheel drives.
Okay, maybe that's that's specific code. So we can discuss all these things, card technology. Right, that you have rightly pointed. Then engine. Then there may be 2 engines or wheel. There four is the minimum number of wheels. There may be stepney wheels. There may be all the wheels will be there, right? Few the track will have more wheels, and the speaker there may be 0 to 1. There may be 3 4 5 6 speakers. So these are the kind of specific design, right? So depending upon the car model, we can design these things, right? But these are called multiplicity. Multiplicity means how many small objects the car owns. Okay,
Can you show me how to create one?
how to create one? So let me.
Just
So
create another employee one quickly.
yeah, I'll
Because
take
it's
it.
quite simple.
So I'm deleting it. Yes, well, okay, deleting it. So I'm clicking on class, class. Okay, this should be employee. And then what you will do here, you will, yes, okay. So here you will basically, what you will do, you will add attributes and method. So let me show you what is an attribute. Say let me show add attribute. Okay, add attribute. So see, attribute has already become minus because minus stands for private. Okay, minus, see attribute, you are able to see the attribute, right?
Yeah.
Attribute is minus. See attribute, so if I give the attribute, say first name, and this should be string, right? First name should be string, right?
Yeah.
And then what I will do, I will show you something else. This is what we have done. So then we will do attributes. So add attributes with greater than setter. Say I will give the greater than setter. Okay, I'll give attributes. Say last name.
Yeah.
Last name. See already it is created greater than setter. See it already created get last name, set last name, right?
Yeah.
So then what was there? Then what was there? Age, right?
Age. By the way, I forgot to create getter setter first name.
No, I'm just showing you what are the different ways. So this way, these are depicted string. Last 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 name is string.
Can I
Okay.
try to create an employee? I'll try to create an employee myself.
Yeah, you can do it. So you can do it. You can try your hand at home, and then you can of course try your hand. So this is how, very simple. Once you open it, you will be able to do it. Don't worry. So you just have to explore it a little bit. Maybe this is now your exam time. Maybe you don't have time, but once you get time, you just have to explore it. The other relationships and all these things I've discussed with you. You just have to use a tool. Okay, how you can use the UML, visual paradigm for UML. Okay.
By the way, what is an n-ary association?
N-ary association means 0 to n. N means this is n number. So in indefinite number. There may be 4, there may be 5, there may be 6. Okay. So there are a lot of things, many of the things I also don't know, but I know the major parts because my aim is not to become an UML expert. My aim is to become a Java expert, or maybe the what is essential part of the UML that is needed for my project, for the work. Okay, those things, there are many things. I don't know. Yeah, I don't know a lot of things because then I will become an UML expert. Only do UML diagrams. But that shouldn't be a mode. Many things because and these things are not well documented. Sir. These are not well documented. Okay, UML is a body. UML there is a body globally for designing this UML and all these things. Okay, so those bodies actually decide what should be the notation and what should be all these things. Okay, so let's stop it here today, and I'll be signing up now. And you have already learned the class diagrams. Next day we will try to understand the restaurant problem vis-a-vis the class diagrams. Okay, class analysis. Okay.
Don't forget to stop the recording.
Oh yeah, I'll definitely do that. Don't worry. Okay. All right. So I will do that. So stop. This is stop, right? Stop it.